So again, today we're doing 3-8 and 3-4. We're going to start with 3-8. We did 3-7 yesterday, and honestly, we did some of what we're going to do today yesterday. We did some parallel and perpendicular lines, and that's what we're focusing on today. I'm going to ask for a little bit of help, but I'm also going to do a fair amount on my own too. So if you have any questions or if you have something you want to share, please, please, please be free to ask. So we're talking about parallel and perpendicular lines, so we're just exploring that a little bit more in depth today. Remember that two non-vertical lines are parallel if and only if their slopes are the same. The reason I say non-vertical, I have to specify that, is remember that vertical slopes have an or vertical lines have an undefined slope. And undefined is just anything with 0 in the denominator. So it could be like 2 over 0. It could be like -7 over 0. It could be like 512 over 0. So those are technically not the same, but they all have 0 in the denominator, which makes them undefined. But we specify by saying non-vertical lines will have the exact same slope because vertical lines could not have the same and still be vertical and still be parallel. Another thing to note, all vertical lines are parallel, all horizontal lines are parallel. So that's just a good thing to notice. First thing we're doing is we're checking to see if these lines are parallel. So I gave us two lines. Line 3 has the point -13.6 and -1.2. And then line 4 contains 3.6 and 6.7. We want to see if they're parallel. Well, we can see if they're parallel by seeing if their slopes are the same. Are their slopes the same? That's what I'm asking myself, and that's what we're going to find. So let's work smarter, not harder today. Let's do this. Let's split up the work. So girls, why don't you find the slope of L3? And then boys, you find the slope of L4, and then we're going to compare them. I'll do them both, but you do yours first. So girls do L3, boys do L4, and then we'll compare. Okay. All right, I found my slopes. Did you guys find yours? I got -1/3 for L3, and for L4, I got +1/3. Are those the same? Anybody with me today? Are those the same?
Yes.
No.
No.
I don't think they are.
Why not?
I don't think they are either. I don't know why.
One's negative and
The
one's
negative,
positive.
yeah.
There we go. We're all alive now.
There you
One's
go.
negative and one's positive. They're not the exact same. So they have to be the exact same in order for them to be parallel. And these are not. So we're going to say they are not parallel. Not parallel. All right, now we're going to write equations for parallel lines. All right, the first one says, what's the equation of a line parallel to y equals -x minus 7 that contains -5, 3? What's the slope of this line?
-1.
-1. Am I going to use that, or am I going to do opposite reciprocal?
Opposite.
If they're parallel?
I'm not going to use it.
Use it. Very good. So that's why I went back to the problem that said parallel. I'm going to use -1. So that's my slope, and this is my x1, and this is my y1. Who can write my point slope form equation for me?
Y minus 3
Uh-huh.
equals -1 parentheses x plus 5.
Very good, Colin. So we put in our y minus 3, and then -1's my slope, and then we made it a +5 because it was minus a negative. Awesome. All right, that's all that one wanted. Now I need to get it into slope-intercept form, so what do I do? Anybody?
You put 3 equals -1. I mean, yeah, -1 parentheses -5
Mm-hmm.
-7.
Not -7. We want to figure out this variable, so we're going to put plus b.
Okay.
Remember, if we're going to solve an equation, we need a variable. This -7 actually means nothing, so you could have crossed them off right at the beginning. All right, other than that, good job, Kamara, way to plug it in. So now I'm going to solve, so I've got 3 equals 5 plus b, and then -5 from both sides, -2 equals b. If you had taken the point slope form and just solved for y, you would have gotten the exact same thing. Once I find b, though, I'm not done. I have to put it into y equals mx plus b. So y equals -x minus 2 is my final answer. And you should get that either way you do it. All right, any questions? That was our parallel line practice. All right, the next one says slopes of perpendicular lines. So let me talk for a minute and then I'm going to need some help. It says 2 non-vertical lines are perpendicular if and only if their slopes are opposite reciprocals. As we said today, opposite reciprocals, opposite refers to my signs. And so if I was at a negative, it becomes a positive. And if I was a positive, it becomes a negative. So that's what opposite means. Reciprocal means that we flip it. So like if I had 1/2, that flips to be 2. If I had 5/6, that flips to be 6/5. So those are just a couple examples. So we have to do both the opposite and the reciprocal in all of these. Any horizontal line is perpendicular with a vertical line. Because they go on and on forever, they will always make a 90-degree angle, being straight horizontal and straight vertical. All right, now we need to find if these lines are perpendicular. So just like last time, we're going to split up the work. Girls, again, you're going to find what the slope of L3 is. And then boys, you're going to find the slope of L4. And then we're going to compare the answers. So you find the slope. We want to know if the slopes are opposite reciprocals of each other. So take a second, find your slope. All right, did you find your slopes? Are these lines perpendicular?
No,
Why not?
because -8's reciprocal is 1/8 positive.
Perfect. So you knew based on the slope that you found what you were looking for the next one, and it wasn't correct. So we know that they're not the same. We know that they're not opposite reciprocals. Same thing if someone found the slope for L4, they're like, okay, well, the other one should be -10. Well, that's not the case. So these are just not perpendicular. Remember the symbol for perpendicular is that like upside down capital T. I'm going to be using it a little bit more now that we've talked about it a couple times. So know that that's what I mean when I say that. All right, now I'm going to need some help on this next one. It says writing equations of perpendicular lines. So just like we did for parallel, we're going to do down here. So what is the equation of a line perpendicular to y equals negative 3x minus 5 that contains the point negative 3, 7? Okay, my first question is what's the slope of this line right here? What's the slope of the line you see?
-3.
Negative 3. Am I going to use that or am I going to do opposite reciprocal?
Opposite reciprocal.
Good. And what is the opposite reciprocal of this?
1/3.
1/3. Awesome. Thank you. Lydia and Nolan tag team that one. M is equal to 1/3. So I'm going to use M as 1/3 and I'm going to use my X1 and my Y1 and I'm going to do point slope form. So who can help me with point slope form?
Would it be y minus 7
Mm-hmm.
equals 1/3 and then x plus 3?
Perfect. Good job, Kate. All right. Y minus 7 equals 1/3 x plus 3. That is all I need to be in my point slope form. Now I need to go to slope intercept form. Who can do that for me? There's a couple different ways you can do it. So there's a lot of correct answers. What do I do?
I said 7 equals 1/3 times negative 3 plus b.
Perfect. So Abby said that she plugged it back into y equals mx plus b. She used her 7 for her y. Her slope was 1/3 and her x was -3. And she used b to find my slope intercept. Now, some of you might have been quiet because you're like, oh, I don't really want to do fraction multiplication on this dreary Tuesday morning. Well, 1/3 times -3 is the same thing as multiplying by -3/1. You can do this two ways. You can multiply the numerator and then multiply the denominator. So -1 times -3 is -3. 3 times 1 is 3. And then you know that -3 divided by 3 is 1. What you also could have done was known that we could cancel out. If I have a 3 in the denominator and a 3 in the numerator, those guys cancel out and I am just left with 1 everywhere. So the top will be 1 and the bottom will be 1. The only thing is it's got to be negative, so don't forget a negative with your 1. If you were nervous about the multiplying fractions, that's all that is. So I have 7 equals -1 plus b, and then I add 1 to both sides, and I get 8 equals b. And I'm not done until I put it in my final y equals mx plus b form. Y equals 1/3 x plus 8. All right, any questions? Okay, we're gonna do a couple practice problems. I believe these are the same that we did yesterday, so let's actually rewrite them. I'll double check, but I believe I just copy and pasted last year. Yep, I did. All right, I'm just gonna rewrite this. Let's say -2x plus y equals 7, and it still is gonna go through that same point. And then this one down here, I'll rewrite this, and I'll go back to this when we get to it, but I'll write this as, I don't know, y equals 5, oh no, I lied. 3/4 x minus 1. So I'm going to leave the points the same. I'm not changing these, but I just changed the equation that we're parallel to or that we're perpendicular to. All right, we're going to do the first one together. All right, my first question is, what's the slope of this line right here? Who have I not talked to? Who can help me?
Is it -2/1?
It is right now, but let's get y by itself. How do I get y by itself?
Would you add the 2x on both sides?
Good. So now that I have the y by itself, what is my slope now?
2x or 2/1.
Perfect, 2/1. All right, thank you, Cooper. Somebody else, am I gonna use 2/1 or do I need to change that?
You're gonna use it.
I'm gonna use it, right? What tells me that? What tells me that I get to use that slope?
It's parallel.
Perfect. Keyword is parallel. Thank you, Kate. All right, and then now I need to do my slope intercept form. So you can put it in whatever form you want, but we have to get it down to y equals mx plus b. Who can help me with the equation part? Somebody new.
Miss White.
Yeah.
Where did you get the 7 from? I'm sorry.
I just made it up.
Okay.
Yep, good question. All right, who's gonna help me? Do I need to call on somebody? Yeah, we feeling shy today? How about Caleb? Can you help me? Caleb, you there? Nope, okay. All right, someone tell Caleb to talk to me. Who else can talk to me? Let's do, Billy, can you help me?
Yeah.
Awesome. So you can either plug into slope intercept form or point slope, but we need to get it down to y equals. Do you want to do point slope or slope intercept?
I'll do slope intercept.
Perfect. So plug in to y equals mx plus b so we can find b. What goes for my,
So would it be y equals 2x minus 1/2?
well, we don't know what b is yet. Why don't we use 1 and 2 for my x and y?
Okay.
So let's take out x and y. What goes for y?
2.
Good. And then what goes for x?
-1.
Awesome. There we go. All right. And then now we'll find b and then we'll be able to plug in easily. So I do -1 times 2. So I get 2 equals -2 plus b. And then I add 2 to both sides to get 4.
Okay.
And then now we're ready for y equals mx plus b. And what do we get?
Y equals, is it 2x plus 4?
Very good. Yep, that's it. Awesome. Thanks, Billy. All right, Billy, you're off the hot seat. All right, next problem. Anybody questions on this first one before I move on? All right, this next one, what is the slope of the line that's written right here? What's the slope of that line?
3/4.
3/4, good. Somebody knew, thank you, Colin. Somebody knew, what, am I gonna use 3/4 or do I need to change it?
You're gonna change it to 4/3.
4/3, I need one more thing.
Would it be negative?
It would be negative. Don't forget that negative there. So we gotta flip it and we gotta make the negative. So I change it to 4/3 because it says perpendicular. All right, now I need to put this in point slope form, and it's easiest to just put it right in that form. What is my point slope form? Can someone help me with that?
Isn't that y equals mx plus b?
Nope, that's slope intercept. Point slope's the other one.
Oh, and it's like a equals something plus c.
No, you're thinking standard form. I want y minus y1 equals m times x minus x1.
Would it be y take away 4
Mhm.
equals -4/3, and then in parentheses, x take away 3.
Yep, very good. Thank you, Ella. Y minus 4 equals -4/3 x minus 3. Good job, guys. All right, I think some of us are a little sleepy, so make sure that we wake up before you try the homework. This is all stuff that we did yesterday. We just spent a little bit more time focusing in on it. Are there any questions on parallel or perpendicular lines? Okay, we're going to move to the next lesson, which is 3-4. And 3-4 is not really mathy. It's a little bit more logic-y. So there's 3 theorems there that we're going to learn. It's just a 2-pager of notes, and we'll kind of fly through it. But if you have questions, please let me know, because it's not really something that I can plug in and prove. It's just like, this is a theorem, and this is how we're going to reason our way through it. All right, does everyone have these notes out? Ready to go? As I think I said this, but if I didn't, I'm going to repeat it. The homework is just like the notes we did a second ago. So this 3-4 isn't really on your notes, but because we have time today, we're going to do it as well. So again, if you don't fully understand this, we'll get you caught up later, or you can rewatch this video and see what's going on. But for the most part, this is just kind of logic reasoning stuff in this lesson. So as I said, there are 3 theorems here, and they're all relating to parallel and perpendicular lines. So the first one's called the transitive property of parallel lines. Oh, you guys have gotten really good at transitive. We'll be good at this one. It says if 2 lines are parallel to the same line, then they are parallel to each other. Basically, if A is parallel to B and B is parallel to C, then that means by transitive, I can just cut out that middleman of B and go directly to A is parallel to C. I also have a picture that demonstrates that too, if you want to see it as well. A and B are parallel. Remember, the little arrows on the line mean that they're parallel. And then it says B and C are parallel. On this time, I've got 2 little arrows to represent that these 2 are parallel themselves. But if A and B are parallel and B and C are parallel, then I can just cut off the B in the middle and go right to A and C are parallel to each other. That's what we call the transitive property of parallel lines. So those are just how parallel lines relate to each other. If the 2 parallel lines are parallel to the same line, then they're parallel to each other. The next 2 deal with parallel and perpendicular lines. So we're going to see what that looks like. It says in a plane, if 2 lines are perpendicular to the same line, then they are parallel to each other. M is perpendicular to T and N is perpendicular to T, so M and N are going to be parallel. A common mistake, what a lot of us want to do is we want to cut out the T's and we want to go directly to say, oh, M and N are perpendicular. Well, let me show you a picture of why that doesn't work. If M is perpendicular to T, and N is perpendicular to T, they both have opposite reciprocal slopes to T, so that means that they are going to be parallel. They're going to have the same slope. So M is parallel to N. That's a common mistake. Okay. I ask, why did I say in a plane? The reason is if it's not in one plane, they could be skew. The lines, let me rephrase that. The lines could be skew if they're not in the same plane. You would think I would have bought a tissue box between last week and this week, but I didn't. So I wish I could show you what I'm talking about. But essentially, you could have like one line be perpendicular to this line, and then I could have another line going like this way that's also perpendicular to it. Again, kind of poor. It's hard to show it in 3D, but what I'm saying is that I'm always going to do this in a plane in one 2D setting. Because if not, then they could be skew and not parallel. All right, and then the last one's a perpendicular transversal theorem. So it says in a plane, if a line is perpendicular to one of 2 parallel lines, then it is also perpendicular to the other line. So what that's saying is what was given to us is that these lines L and M are parallel, and then N is perpendicular to L. Because these are parallel, then N is not just perpendicular to L, it's also perpendicular to M. So I like to think of it as an if-then. If L and M are parallel and N is perpendicular to L, then N is also perpendicular to M. In 3 lines, you can have 3 lines that are parallel, or you can have 2 lines that are parallel and 1 that's perpendicular to it. So like perpendicular, all 3 can't be perpendicular to themselves. Only 2 can be perpendicular to each other. So if you have like 3 perpendiculars, then something's wrong. Okay. Any questions? Anybody want me to talk any more about those? Okay, let's do some examples. I can't see your faces, so I have no idea how we're doing. So you got to make sure you're vocal if you don't know what's happening. Okay, in this picture, it says fill in the blanks. C is perpendicular to what? Okay, C is this line, perpendicular sign, so it's perpendicular to?
P.
We don't know that yet. You're jumping too fast, Cooper. Which one is it written that it's
Oh,
perpendicular?
N.
N, good. It's written that it's perpendicular to N, so we're just working our way through it.
But what do we know since it's, a line going through P? What do we just know? It's.
We're going to know it in 1 second, but what I'm doing is writing the things I know first. So
Okay.
I only know this because it's written. I
Right.
also only know N is parallel to which line because they're written.
P.
P. Good. And then now I can assume, Cooper, that C and P are perpendicular.
Okay.
See how we got there?
Yep.
Awesome. Okay. It's going to be super helpful on these next 3 to draw pictures. So I'm going to kind of draw pictures into like this blank space over here and number them. So I'm allowed to see what's going on. So the first one says if G is
So
parallel,
what do those arrows on the line mean?
those mean parallel.
Okay.
So if I have, so you see how the lines have like their arrows at the end, but then it's got like another arrow in the middle. That means that they're parallel to each other.
Okay.
Okay. So if G is parallel to H and H is parallel to J, then what? So let's draw that. G, I'm just making this up. Just drew a line. G is parallel to H. So I'm going to put little arrows on them to show that they're parallel. And then it says H is parallel to J. So H and J are parallel. G and H are parallel. H and J are parallel. So I can assume what else?
The G and J are parallel.
G and J are parallel. Good. So these guys.
What's the double arrows?
It's just another way to do perpendicular, or sorry, parallel.
Okay.
Since
Okay.
I know that G and H are parallel, H and J might be different parallel. So I do a second arrow. When we get into 4-sided figures, we'll do like the 1 arrow for one direction. I don't know why my iPad is lagging. And then I can do 2 arrows on the other one to show that these guys are parallel in 5 years when it shows up. Okay, I think, is my Zoom the one messing up?
Yeah, your internet's going to get everything, but it's good.
Yeah. Yeah, so the double arrow, I see myself freezing. Okay. I don't really know what to do to fix that. Well, that's going to be tough. Okay, let's see if I can. No. Let's. Okay. So you guys just hang tight on this Zoom. I'm gonna try to do 3 and 4. If I get that far. Okay. Okay, I don't know. I don't share my screen. Maybe, maybe not. Okay, I don't know if I'm better or not, but I'm gonna keep talking. So I tried to shut off my internet a couple times. I'm sorry that it's
You're good now.
better now. Okay, I'm sorry it's been crazy today. What I was looking for in this first one, and I think somebody answered me, G is parallel to J. Okay, the next one says in the same plane, if M is perpendicular to N and M is perpendicular to P, then what do we know? Again, let's draw it out. M is perpendicular to P, and M and N are also perpendicular. So those are the two things we know. That means that what is the third thing that we know from here? I know M and N are perpendicular and M.
N is parallel to P.
Perfect. N and P are parallel. Very good. N is parallel to P. And then the last one, it says F is parallel to K and F and G are perpendicular. Okay. So F and K are parallel. Pretend that's parallel. And then G and F are perpendicular. So those are the two things I know. And what's the third thing I get to know?
G and K are perpendicular.
G and K are perpendicular. Very good. So G and K are perpendicular. Okay. In my other class, we didn't finish all these examples, and so we're just not we're going to skip these for now. We'll look at them next Mission Monday or next time in person. We'll do it another time. But since my internet's been kind of spotty and you guys have done a great job with notes, we're going to call it a day for now. Are there any questions on this paper before I go?
I have a question.
Mm-hmm.
So, okay, so when on the fourth one, could we say, is it just G is perpendicular to K, or can we choose either one, F or K?
Well, it already.
Oh, never mind. I'll figure that out.
Yeah.
Okay.
Yes. So that's a great question. And that's a good way to check yourself, because sometimes people want to be like, oh, well, F and G are perpendicular, but you don't want to state something that's already been stated. So kind of make sure you've covered all your bases, and there's only 3 pieces of information. So there's really just one answer left. All right. Okay. I'm going to stop my share. I'm going to stop my record. I feel bad